This last lesson is actually just a review lesson, just to review a lot of the concepts that you've already done. So you don't really have to watch the videos if you've already got it, but if you want to watch these videos just as a refresher, great. So when it comes to solving logarithms, just as a refresher, remember if you see a log that does not have any variables in it, chances are it simplifies to an integer answer. So for instance, log base 7 of 343 is 3. So I have 3 minus 2 log base 7 of x equals 5. Now the next thing you need to remember is to isolate the log. So I need to get the log by itself first. So I'll subtract 3. So negative 2 log base 7 of x equals positive 2. And I'll divide both sides by negative 2. So log base 7 of x equals negative 1. And then the last thing we need to do is get rid of the log by applying the inverse to both sides. So I'll do base 7, so that will get rid of this log base 7. So we have x equals 7 to the negative first, or 1/7. And 1/7 is greater than 0, so it's not going to make our argument 0 or less than 0, so we are good to go. So let's do another problem. Oh, I thought there was one on this page. Nope. Let's go to another one. So once again, as long as there's one log per side, I don't need to condense or anything. So I'm going to go ahead and just apply an inverse. So I match that base. Those cancel out. I end up with x squared minus 5x minus 7 equals x. Now since there is a quadratic that also has a linear term to it, so that 5x, that tells me I'm going to have to get this all equal to 0. And then factor, our favorite thing, if you couldn't tell. We love factoring. So this factors to x minus 7, x plus 1. So we've got x is equal to positive 7 and x is equal to negative 1. And then we just need to check both of those to make sure it doesn't make either of our arguments negative. Which 7, and we got to check both. So 7, if I do 7 squared minus 5 times 7 minus 7. 7 squared is 49. 5 times 7 is 35. So 49 minus 35, and then subtract another 7. That gives you 7. So that one's good. And if I put 7 right there, we're great. However, negative 1 would give us a negative argument. So this one is extraneous. And I can tell that just because if I put it into this argument on the right side, it's automatically negative. All right, let's do another one. So here's a prime example, once again, of logs with multiple logs on one side. So we need to condense, so we need to distribute. And it'll still be in a log, so I don't get rid of the log. I'll have log base 3 of x squared plus 2x plus 3x plus 6. All that's going to be equal to log base 3 of 5x plus 7. So I went ahead and distributed. I'm going to go ahead and combine like terms. So I have log base 3 of x squared plus 5x plus 6 equals log base 3 of 5x plus 7. Now remember, the only way you can get rid of a log is by applying the inverse. The inverse would be, in this case, applying a base 3 to both sides. And it will get rid of, since both sides have a log, it'll get rid of both sides' logs. So I have x squared plus 5x plus 6 equals 5x plus 7. And I'm going to go ahead and get this equal to 0, since I know I'm going to have to factor, since there is an x squared term. So I have x squared minus 1 equals 0, so I'm going to have two answers. And that factors to x squared plus 1, x squared minus 1. So x is, if I find my zeros, x is equal to positive 1 and negative 1. Let's check to see if either one of these are extraneous. So I'm just going to go argument by argument. So for the first one, I have 1 plus 3, so that's positive. The next one's 1 plus 2, that's also positive. 5 times 1 plus 7 will also be positive. So 1 works. Negative 1 plus 3 is positive, negative 1 plus 2 is positive, and so is 5 times negative 1 plus 7. So both of those actually end up working.